All right, in the last part of section 6.1, 6.2, we're going to be talking about the area of triangles using a different formula. So if we have a triangle, we're going to use ABC like we did for law of sines, A, B, C. The area of a triangle formula that we're used to using is base times height. And remember, the height would always be perpendicular to the base. And you could always use whatever side you wanted as your base. Like if you wanted to, you could go from point A perpendicular to side A. Okay, now side A is your base, and this dotted blue line would be your height. Or like I drew originally in pink, where the side B is my base, and that pink line is the height. So you could do it any way you want. So the formula that we use for area of an oblique triangle is area equals 1/2 B times C times the sine of A, or area is 1/2 A times C times the sine of angle B, or area is 1/2 AB times the sine of C. So this only works if you have side, angle, side. So two sides and the angle between them. And if you look at the picture with the formulas we wrote down, it makes sense. 1/2 BC times the sine of A. Well, side B is right here, side C is there, and angle A is touching both of those sides. AC times the sine of B, well, here's C, here's A, and B touches both of those. So this is just the same formula written three different ways depending on what information you are given. And then if we need to, we can always use law of sines or law of cosines to get some extra information. Now, if you only know all three sides and no angles, we can use Heron's area formula. And what that is the area is equal to the square root of S times S minus A times S minus B times S minus C. And S is the semi-perimeter. Well, what is a semi-perimeter? It's when we add up all the sides and divide by 2. Like a semicircle is half of a circle, semi-perimeter is half the perimeter. So we have to figure out that S value, that semi-perimeter, first, and then we can use that area formula. Actually, I want to switch this to a capital A so we don't get confused with the side A. Okay, so on the next page, we're going to find the area of these two triangles. So we always want to draw a picture, because you may say, oh, I have two sides and an angle, it must be the this formula here. But what if one of these sides doesn't touch the angle that we have? Then we have to do some extra work. So we have A, B, C. Angle B is 120 degrees. Side A is 32. And side C is 50. So in this case, we do have the two sides that touch the angle we're given. So we can just use the area equals 1/2 times the two sides times 32 times 50 times the sine of 120 degrees. So in our calculator, we can type that all in to one step. 1 divided by 2 times 32 times 50 times the sine of 120 degrees. I'm going to make sure I'm in degree mode. I am. And we get 692.82. Now they didn't give us any units, so we don't need to write like inches or anything like that. Sometimes people will write units, square units like that. But just we want to make sure that they don't give us a specific unit to use. So then letter B, well, we have three lowercase letters, so we know it's going to be the three sides that we're given, A, B, C. Side A is 31, side B is 52, 28. So this is an SSS situation. So first we have to figure out the semi-perimeter. That's all three sides added up, 28 plus 31 plus 52 divided by 2. Now if you're doing this in the calculator, you either need to use parentheses or the fraction button, because if you try to do 28 plus 31 plus 52 and then divide that by 2, the calculator is going to do 52 divided by 2 first and then add the other stuff. We don't want to do that. So we can add that, hit enter, and then divide by 2. We get 55.5. So then the area is equal to the square root of 55.5 times 55.5 minus 28 times 55.5 minus 31 and it's 55.5 minus 52. So we can type that all into the calculator in one step. So the square root of 55.5 times 55.5 minus 28. Now because we are multiplying, the order doesn't matter. We could have done these parentheses in any order. And make sure we close our last parenthesis. And we get 361.767, so we'd run that to 0.77. 61.77, again, square units. So just using these formulas aren't hard to use. You just have to recognize when to use them, and that to be mindful that you may not have the necessary information right away. You may have to do a law of sines or law of cosines in order to get some piece of information to calculate the area. So now we're going to focus on word problems, and remember we've done bearings before at the beginning here, and when we talk about bearings, it's always in relation to north or south. So remember, the south 35 degrees east is like we're starting south and then we're going east 35 degrees. North 85 degrees west means we're starting north and then we're going 80 degrees west. And then north 45 degrees east, we're starting north and then going 45 degrees east. So you're always going to have a north or south first, and then you're going to go east or west depending on the angle measure. The tricky thing about these problems is you have to realize where we're starting from. So if we look at example 2 right here, if I start at point A, the bearing to point C is different if I were then starting at point B and going to C. So we're going to have a few different mini problems here to look at these bearings. So it says a bridge is to be built across a small lake from B to C. The bearing from B to C is 40 degrees west, or is south 40 degrees west. So from B to C means this is like my origin right here, and south, and then 40 degrees to the west, so this way. So this angle right here is 40 degrees. A 100, from point A, 150 meters from point B. Okay, so that means this is 150. And then the bearings to B and C are 75 south 75 degrees east and south 30 degrees east, respectively. Find the distance from B to C. So let's go back and make sure we have all this information in correctly. And we want to label our triangle with all these other bearings. All right, so the bearing 2B from point A is 75 degrees. So I'm going to do this here to kind of make it easier. It says 75 south 75 degrees east. So south and then 75 degrees east. So this angle right here is 75 degrees. Now it also tells us, this isn't a very good line right here. Well, let's go back and do that 150 there. It also tells us that the bearing from A to C is south 30 degrees east. Okay, so south and then 30 degrees east is only that part right there. So what that means is that this small angle here in the triangle is going to be this whole 75 degrees that I have in purple minus the 30 degrees that I have in green. So I'm going to draw this triangle over here to make it a little bit easier. We now know that this angle is 45 degrees. We know that, and I'm going to label A, B, C. We know that this distance is 150. We're trying to find that distance there. Now that 40 degrees is not inside that triangle. However, we could use our parallel lines and transversals, which would make this angle, oops, someone used purple, this angle 40 degrees, and this angle here would be 30 degrees because of this parallel line here, which would make the total 70 degrees. All right, so now we can use one of our laws, sines or cosines, because we have three pieces of information. We have two angles and we have a side. So we're going to do the sine of 70 degrees over 150 equals the sine of 45 degrees over x, what we're trying to figure out. So then we cross multiply and divide. So we have 150 times the sine of 45 degrees over the sine of 70 degrees equals x. So I type that into my calculator and I get about 112.87 meters because that's the units we were given right here. So these bearing problems can be confusing because the angles that were given may not be the exact ones we use in the problems. We really have to think about where those bearings would be in our picture and if they are useful inside our problem. All right, so example 4 says on a map, Minneapolis is 170 millimeters due west of Albany. So that means directly west, with no bearings north or south. Dallas is 215 millimeters from Minneapolis, and Dallas is 370 millimeters from Albany. So I'm going to draw this out. I have Albany, and then due west is Minneapolis. And then Dallas, I'm going to put Dallas down here. And then let's label. This is 170. Dallas is 215 millimeters from Minneapolis, and then this is 370. The question is asking us the bearing of Minneapolis from Dallas and the bearing of Albany from Dallas. So let's figure out what this angle is right here, and that will help us with our bearings. Now, we want to be careful because when we talked about the law of cosines the other day, we said we always wanted to find the largest angle first. So before I find angle D, I'm going to have to find angle M first. So we're going to use our law of cosines. So 370 squared is equal to the sum of the other two sides squared. So 370 squared equals 215 squared plus 170 squared minus 2 times 215 times 170 times the cosine of M. So let's type this stuff into the calculator. So 370 squared is 136,900. I'm going to add those two in the calculator. That gives me 75,125 minus 2 times 215 times 170. That gives me 73,100 times the cosine of M. So then we need to get the cosine of M by itself. We'll subtract 75,125 from both sides. And that gives me 61,775. Then we can divide by negative 73,100. So we get negative 0.8451 equals the cosine of M. So then the inverse cosine of negative 841, I get 147.68 degrees. So that gives me the largest angle. So now we can figure out the other angles. I'm going to switch to the law of sines to find out angle D, because it is the smallest angle because it's across from the smallest side. So the sine of 147.68 over 370 equals the sine of D over 170. Cross multiply 170 times the sine of 147.68 over 370 equals the sine of D. Type all that into the calculator. 170 times the sine of 147.68. And I get 0.2456 equals the sine of D. So then the inverse sine of 0.2456 gives me 14.22 degrees. So this is 14.22 degrees. Okay, so now with that, we can develop a plan on how to get these bearings. Since we're coming from Dallas, what I'm going to do is I'm going to make Dallas my origin and draw my axes through that. With our axes drawn, let's try to come up with a plan to what we're trying to do. So we're going from Dallas to Albany, which is going to be this whole angle right here. That's going to be my bearing from Dallas to Albany. Now from Dallas to Minneapolis, that's going to be this angle right here. Now we know that we have a corner, a 90-degree angle, and we also know that angle D is 14.22. So let's figure out what this angle is, because then we can start subtracting to figure things out. So angle A is going to be 180 minus 147.68 minus 14.22, which is going to give us 18.1. So this angle up here is 18.1 degrees, which is going to be the same as this angle because of alternate interior angles and parallel lines. All right, so now this looks a little bit confusing with all those lines there. So I'm going to redraw that. We have all this space here. So I'm going to redraw that. And we have two lines coming from there. This angle is 18.1. This angle is 14.22. We can figure out what this angle is now by doing 90 minus 14.22 minus 18.1, and that gives us 57.68. So now if we take that over to our main image, that's what this purple angle is right here, 57.68, which is what we're trying to figure out from the original problem that says, the angle from Dallas to Minneapolis. So Dallas, let's just abbreviate it. D to M is going to be north 57.68 degrees east. Because from north, straight up and down, we went east 57.68 degrees. Now we got to figure out that red marking. Well, that red marking, if we go back to our zoomed in picture, that red mark is this part right here. So 57.68 plus 14.22, that's going to give us 71.9. So then Dallas to Albany is north 71.9 degrees east. So this problem had a lot of small steps involved, and we just had to be careful with the information that we were given and using that to find the other parts. All right, now let's do example 5. So the ship travels 60 miles due east, then adjusts its course northward as shown in the figure. So this is 60. After traveling 80 miles in the new direction, the ship is 139 miles from its point of departure. So its original point to its ending point is 139 miles. Describe the bearing from point B to point C. So from point B to C, that means I'm trying to find this angle right here. So what we're going to do first is find out what angle B is, this whole angle for angle B. So in order to do that, we're going to have to use the law of cosines, and luckily for us, angle B will be the biggest angle, so we just have to find that one first. So then the law of cosines, we have 139 squared plus 80 squared plus 60 squared minus, oops, sorry, this is equals, minus 2 times 80 times 60 times the cosine of B. So 139 squared, we get 1,000 or 19,320 equals 80 squared plus 60 squared, 10,000 minus 9,600 times the cosine of B. So when we subtract, whoops, I forgot one here. Subtract 10,000 from both sides, we get 9,321 equals negative 9,600 times the cosine of B. Divide both sides by negative 9,600. You get negative, oops, negative 0.97, negative 0.9709 equals the cosine of B. Then the inverse cosine of negative 0.9709, I get 166.14 degrees. So that's the angle in light blue right there. So if we look at that angle in light blue, and we know that that is 166.14, we could figure out what this angle is outside the triangle, because this straight line should add to 180. So 180 minus 166.14, so 180 minus 166.14 gives us 13.86 degrees. So now we can use that, because this is a right angle right here, a 90-degree angle. We can use this and do 90 minus 13.86 to give us our bearing. So 90 minus that, I get 76.14 degrees. So then my answer is going to be north 76.14 degrees east, because from north I'm going east 76.14 degrees. So again, these bearing problems can be confusing, because you really have to think about where the problem is coming from in order to have the right central location. So this problem, we had to start from B, because we were asked from point B to C. If we were asked from point A, all right, then the whole setup would be a bit different. All right, so thanks for watching. Make sure to like and subscribe.